Hello, I'm John Bryan. Welcome to my shop. Let me show you what I've been working on. This is my 1946 Logan Model 200 lathe. And right there are all of the change gears, which I replaced with this. There's an encoder driven by the spindle. There's a stepper motor driving this timing belt. And it works like this. Before this upgrade, I had to use this chart to select the arrangement of change gears for the feed rate or thread pitch that I wanted to cut. Okay. 30, 12, 13, 13. Dang. Now, with 21st century technology, I do it like this. And like this. And like this. And like this. So change gears are a pain, but to my mind, what was worse, or more of a problem, was that the crossfeed on this lathe moves twice as fast as the longitudinal feed for a given gearing. And the lowest gearing on that chart is a rate of 4.6 thousandths per revolution. So you think, I mean, almost 10 thousandths per revolution feed when you're facing something. If you're trying to use a cutter with a small radius, you get a pretty rough finish. So I thought, maybe I can run the other end of the, of the lead screw with a gear motor and a simple, little DC control or something like that. But I played with it a little bit. But I finally decided that it made more sense once I realized that I could fit the stepper motor and the encoder into the available space and leave the lathe completely stock so that it could be returned to original condition. I decided that computers were the way to go. It had been a few years since I'd done any microcontroller coding. I remember when 6502s were the thing. So I had to come back up to speed. I settled on the Arduinos. In fact, specifically the Arduino Mega, because I need a little bit more capability for this project than the basic Arduino Uno will give you. I needed more interrupts. I needed more memory. And then I decided that, hey, maybe a touch screen would be a cool thing to do. And what I settled on there was a Nextion touchscreen. They make a Nextion. They make a whole line of different sizes of screens. This is down toward the smaller end of the scale, but not the smallest. Their color, they're fast. They would offload all that graphics from the Arduino, so that I would have the time to keep up with that spindle, because what I wound up with was on the spindle encoder was a resolution of 800 counts per revolution on the spindle. So that works out to about, you're almost interrupting that you've got a spindle tick coming by every 50 some microseconds. At 1500 RPM, and you don't have any time to waste. The stepper motor and controller that I settled on, I actually got from Banggood. It's a micro stepper, and it has a wide range of settings. What I wound up with was 1,000 steps per revolution on the micro stepper, on the stepper motor, and then that goes through a 4-to-1 reduction to drive the 8 thread per inch lead screw, which means I wind up with 32,000 steps per inch, which is 30 some micro inches per step, which seemed like that ought to be pretty reasonable. So next, let me show you what the everything looks like in the enclosure with the Arduino and the controller and the power supplies and how it's all wired up. I'll have to pardon the handheld portion here because I'm a little cramped for space. Inside the enclosure here, you'll see, working backwards, I guess, this is the driver for the microstepping motor. This is the Arduino, which is plugged into a DIN rail terminal block adapter to make it cleaner to wire up. There's also a breadboard sandwiched in there because I had to have a few little resistors and capacitors, things to get from the display and the encoder knob up above into the Arduino. And then there's the power supply. I'm running the whole thing at 36 volts. And then I'm also supplying and I have this little converter that gives me the 5 volts to supply the Arduino. This old Toshiba notebook computer is my development platform. So far it's working out pretty well. You can see I extended the mounting bracket for the switch, mounted the user interface here, the touch screen and the knob, to the extended bracket with a friction hinge so that you can adjust the viewing angle. And let's see, I don't think I've mentioned this knob yet, and this is just a 20 step per revolution encoder. Pretty basic stuff, but it's mechanical. Well, it's kind of noisy, which is why I had to have a few extra resistors and capacitors down below there. I had to add some filtering to the lines coming off of the encoder. It comes up in this screen, defaults to inch rates. I have, I believe, 80 pre-programmed rates from 0.5 up to 4 threads per inch that you can choose from. I just arbitrarily topped out at a feed rate of 250 thousandths per revolution, which is moving right along if the lathe's spinning very fast. Let's see, the way things work out, 40 threads per inch corresponds to 1 step per spindle tick. That is the one-to-one correspondence, and so that's just, I just decided that that would be my default on power up. In metric mode, you always see the rate, and it roughly corresponds to the same range from 1/100th of a millimeter, which is, you know, approximately 4/10, up to 6.5 millimeters per revolution. Diametral, your finest diametral pitch, it would be a 1-inch gear with 120 teeth, which would be a pretty fine tooth gear. And I implemented, let's see, every diametral pitch that I could find on McMaster car. Same thing on module pitches. Actually, the same thing on metric and inch. I went through and looked at every tap that was available, and I looked at every threading plate on every lathe that I could find online, Googling or on eBay. So it's a pretty comprehensive set. I'm considering also allowing you to set an arbitrary pitch for reasons that I will not go into right now, because this is already going long. So this screen behaves like just a normal lathe. You treat it the same way. It's just a programmable gearbox. You can still thread exactly the same way. You know, open and close your half nuts. Uh, it's just normal. The other mode is threading to a stop. In this mode, you notice I'm saying engage the half nuts. When you go into this mode, you want it to work, you engage the half nuts and you leave them engaged. And then I have a jogging function where I can move the carriage. I don't know if you can hear that. I've got a smooth acceleration on that function, so you can adjust things to within 1,000th easily, but you can still get up and go pretty fast when it tops out. So let's say I can arbitrarily set my left limit right there, and then feed back out somewhere. And set my right limit right there. Now, as the little clips I showed earlier demonstrated, it will feed to those points and stop. Now, it's still up to you to feed in and out, you know. But as far as, well, I mean, doing left-hand threading, that's just a matter of, I guess I kind of glossed over the arrows. These select the feed direction. So let's say I just start this thing up, and I'll show you. You can't see the lathe, but you'll see it feed to where I set the stop, which was 500 and something. There. And that's one of my little features. I think I need to add that extra number, that actual location where it stops, to this display. I got to rearrange things a little bit. Anyway, going back the other way. So it repeats within 1,000th of an inch. I mean, it repeats to the step that you select. So let's and other feet. Well, you got to touch the right screen here, guy. All right, so I have this screen, which is not done yet. I can adjust the screen brightness here, and you still get the adjustments, the selection. I just thought it would be nice to have for this lathe to have a table that show the RPMs for each of the belt positions. I plan to update this display to show just the speeds that you can actually use. I mean, you're not going to be feeding at 4 threads per inch at 1,500 RPM. It's but I haven't implemented that feature yet. It might go. I thought about I could either blank the ones that are too high, or I can display that here. It's kind of a little easier if I were to stick it into this hole, um, but it'd be a little sexier if I just displayed the ones that were available. So anyway, let's fire this up. So I disengaged the tumblers. Let me go back. Yeah, wrong screen again. Let me go back here, zero this out. Now the limits are cleared. It'll go everywhere. Let me disengage the half nuts so that I'm not crashing into anything. Let's go back to the setup screen and fire it up. So right now I'm running at 210 RPM, which is it. And so anyway, there's more work to be done here, but that's pretty much the whole thing as it stands right now. So let me wrap this up. Well, if you made it to this point, congratulations. I hope you found at least parts of this interesting. If you like it, hit subscribe. I think the last I checked I was up to 57. And we'll see where this goes. So thanks a lot for watching.